Hello everyone, welcome to Automate with Kaj, where we simplify industrial automation. On today's episode, we will learn how to use the IEC61131-3 programming workspace in the Honeywell Control Edge Builder. So this tutorial is going to be very brief so that we can get into the main thing for this tutorial, doing the Modbus TCP master configuration. So open your Control Edge Builder and let's get started. So here is the Control Edge Builder interface, the first one, which we've talked about in the last tutorial. So for us to use the IEC programming workspace, let's open our project, which we opened in the last tutorial, my Modbus project. So click on it to open it. Okay, now for us to go to the IEC workspace, you can either you go to Control and Programming and select Program with IEC 61131-3, or you select this button. Either of the two works. So let's go here, click it, it will open the workspace. So like I said, I just want to do a brief introduction or an overview of this workspace. So in this workspace, you can see we have the project window. Okay, we have the window for our POUs. Okay, library, hardware, and instances. Then in the project folder, everything is all together. The first thing you can see in the project folder is libraries. If you have a little background in programming, you know that libraries are pre-written code that helps you make your code easier. They are more like abstractions to help us, write our code easier. Then you have data types. So Honeywell gives their programmers the ability to create their own data types so that they can easily manipulate their configuration. Then we have the logical POUs. This is what we use to write our program. All right. By default, it provided one for us already, the default POU. You can delete this and create your own. I talk about the physical hardware. So this is the routine that helps the Control Edge RTU know what program to run first, what program to run last. And you can see this in these tasks here, this task folder here. You can see this one, the root default task. It's a cyclic task, and an instance is created, an instance of that task is created, and it's connected to the default POU. So when we are doing the Modbus configuration, you will see how we will make use of all of this. Okay, so let's just run a little program. Let's create just one POU to see how this works. So let's just insert POU. We are writing a program, and this way you can actually choose what you want to write. You want to write a program, a function, or a function block, and you can choose the language which you want to use. So LD, which stands for ladder, FBD, function block diagram, SFC, sequential function chart, ST, statement list, and instruction list. So let's just use ladder for now. Okay, and give it a name, test. Click OK. Okay, so now a POU is created. You can see this is the variable table, and this is where we write our ladder logic program. Okay, so we can actually now create a network. This is the first network with your contacts and a coil. Okay, you can double click this to make sure a variable is created for you. Okay, and click OK. So how do we know where these variables are? Go to global variables. Okay, not here. All right, here it is. It is in the local variable. It was created here. Look at the input here, COOO. Okay, and for the outputs also, it is saved in the local variable. As you can see here, VAR usage. If you want to save this in the global variable, is to drop down and select global variable. Okay, select OK. And now when we check here, you can find it here. Then we can now compile our project. If you notice, there's this asterisk on the POU. So when we compile, it should clear off the asterisk. So that's just that about the IEC program workspace. So now we're going to put it into practice in the next tutorial. We use it for Modbus configuration. So let's get started.